Okay, so this is another example, slightly different wording, where we're finding point P, which is located at the intersection of a circle with a radius of 3, terminal side of a reference angle that measures 60 degrees. So this piece right here, it says it's a reference angle that measures 60 degrees. So we did the previous example. I'm going to draw a circle. It's going to be a horrible circle, so I apologize for that. But here's our circle. And so it says that we have a reference angle of 60 degrees. So that means this could be our 60-degree reference angle. This could be our 60-degree reference angle. This could be our 60-degree reference angle. Or this could be our 60-degree reference angle. So technically, the way that the problem is worded is I need to find all of these points. Okay, so this is a good problem leading into something called a unit circle that we'll discuss after this section. So the idea here is we're still going to use the same idea, and we're going to use triangles to solve the information that we need. So I have my radius is 3. And what we did in one of the past videos is we had a couple different ways that we did this. We went ahead and we found our x and y values by saying that, oh, okay, well, if sine of theta is equal to y over r, then the radius times sine of the angle is equal to our y value. Okay, so we could do that. Or what we did is we kind of drew this triangle in perspective, and if we know this is 3, we have our other basic triangle where this is in a 30, 60, 90. This is always 2x, this is always x, and this is always x root 3. So we use this idea to fill in the other pieces of the triangle, and this would be, let me label the angle, so this is 60 degrees and this is 30 degrees. And let me see if I can zoom in here. And so what we did is we put the 2x on the inside, and we said, okay, well, if 2x is equal to 3, that means x is equal to 3 halves. So then I focus on my graphical representation of my 30, 60, 90, and I use the algebraic expression that I created here to fill in the missing spots or the missing sides. So if I know x is equal to 3 halves, then I know that this side is 3 halves. And I know that this side is 3 halves times root 3, which is the same as 3 root 3 over 2. Okay, hopefully when I shrink this, it locks everything in place good. And so we now, looking at our pieces, I drew it in the same perspective as this initial triangle. So I now know that this guy right here is 3 halves, and this guy right here is 3 root 3 over 2. Okay, so that makes this point 3 halves, comma, 3 root 3 over 2. The other way to do it is by using this. Okay, and you can use the radius. Okay, we'll find the other points in a second. So I know the radius is 3. Okay, and I know that I'm taking sine of a 60-degree angle, and that's equal to y. So if I use this method that I have down here, what I'm doing is I'm saying, okay, I got a 30, 60, 90, and I know that this is 2, this is root 3, and this is 1, and this might be easier for some of you, so I just take 3 times the sine of that triangle, and I'd get 3 root 3 over 2. I get the same exact answer. Okay, so that would be the other method to find it. So now what I want to look at is it says to find a reference angle that measures 60 degrees. So we talked about at the very beginning of the problem that this is 60 degrees, so is this, so is this, and so is this. So my question to you is, thinking about the fact that these are all 60 degree or 30, 60, 90s, then that means shouldn't these side lengths all be the same? They are exactly all the same. So if I started looking at this triangle and did the same exact thing, the only difference though would be that when I get over to the second quadrant from our previous video, we know that cosine, okay, cosine, which is our x value, right? Because we did the x over r. Well, our x is going to be negative, right? So this would be a negative x and a positive y. So that means I just have to adjust my values so I accommodate for the positive and negative. So that means when I'm down in the third quadrant, that means my x and my y values are negative. And when I'm in the fourth quadrant right here, only my y value is negative. So these three guys, excuse me, four. So if we look at all four of these answers, the numerical value is all the same except for the sign based on the quadrant that you're in. And that's how we would find, and because the problem was specific, it said a reference angle of 60 degrees. All of these guys are reference angles of 60 degrees, so we have to find all four of them.